Hello guys, what's up? So today we are going to solve the Leetcode main challenge day 11 problem, and so let's get started. We are given an image represented by a 2D array of integers, each integer representing the pixel value of image, given a coordinate SRSC representing the starting pixel row and column of flood fill and the pixel color new color flood fill the image. So the meaning of flood fill is basically consider a starting point and plus any pixel connected for directionally to a starting point of the same color as starting pixel plus any pixel connected for that directionally to. So basically we'll have to write kind of first we'll have to go to the starting pixel, and then from that starting pixel we'll have to go to 4 directions: left, right, top and bottom, and we'll have to change the color of those pixels if the color is equal to the starting color. Okay, so let's take one example to understand what he wants. So here we have given an example where the image is like this. So our starting position is 1 1, which I represented by square bracket here, and we'll have to color the image as 2. So here the starting pixel is 1, so we'll basically starting from 1 we'll actually need to so let me just create a layer first. So we'll start from 1 and we'll make it 2 because that's our target or the new color. Now from 2 we'll go to left, we'll go to right, let me just write this here. So we'll go to left, we'll go to top, we'll go to right, and we'll go to bottom. So if the pixel is equal to the starting pixel, so first I go to top. Here the starting pixel was equal to 1 and this pixel is also equal to 1, so this pixel will become 2. Similarly, if I go to left, this pixel equal to the starting pixel, so this will also become 2. Now if I go to right, this pixel is not equal to starting pixel, so we will not change it. Similarly, if I go to bottom, this pixel is not equal to starting pixel, so this will remain the same. Now from 2 I again go to the left pixel which is equal to starting pixel, so this will become 2. For right I'll go to 1 which is equal to starting pixel, so it will become 2. Now at 2 this is already covered, so we will not change it, and at top of 2 there is nothing, so our loop will stop here. Similarly for 0 it will stop because the starting pixel is the current pixel is not equal to starting pixel, so the loop will stop here. So the boundary conditions are the pixel has to be, so let's say image I comma j has to be equal to, or I would say row and column has to be equal to starting pixel, then only you will change, right? So you will change that pixel to the target pixel or target color, right? I would say color, right? The visitor node, because if you are marking the current pixel, you can check if my current pixel is not equal to the starting pixel, then you can skip that. Okay, so let's take another example to have a better clarity. So here I'm starting from 1 which is this, right? And my new color is equal to 1. So my starting color is also 1 and my new color is also 1. So even if I change this, I'll get the same metric, because let's say from 1 I change it to 1, then this will be 1 and this will also be 1. So when my starting pixel equal to new pixel or new color, then I can simply return the image, right? Because so let's just write code for this. I hope this will become clear. So we'll follow a recursive step with the base condition will be when my recursion will go out of the image. So my boundary condition will be my row should not be less than 0. So not less than 0, and row should not be greater than equal to length of image, right? Because in that case it will jump off the image. Similarly, if my column should not be less than 0 and column should not be greater than length of image 0. So this will be my boundary condition. Plus I also need to check if my current pixel is not equal to my starting pixel. So I can simply use this as my combining all of these three conditions, I'll have my boundary condition, and then I'll do that. So let's just write code for this. So we first need to find the boundaries or the number of rows and column, which we'll put like this. So length of image 0, right? If image else 0, right? So now let's just write a recursive function, our recursive function. So we'll call that recursive function like this: fill color with the starting position, starting row and starting column, right? And in the end we'll simply return the image. We will manipulate the image by reference in the function, and we'll return the function and we'll return the image at the end. So my function will be like this: fill color. I am passing row and column here. So as my base case, I will have my boundary conditions. So my boundary conditions will be if my row is less than 0 or my row is greater than equal to length of my image, or I would say n in this case, -1, no, actually n, or my column is less than 0 or my column is greater than equal to m, or my last condition, which is my starting point has to be equal to, my current pixel has to be equal to starting point. So which will be equal to, I would just have a starting point here, maybe starting color I would have, which will be equal to image SRSC, right? I'll put that equal to start color. So if these conditions are satisfied, not equal to, that I will simply return, because in that case I don't have to traverse it. I don't have to recursively walk through those pixels. If that is not the case, I will mark the current pixel as new color, and I will recursively go further, like kind of DFS. So my left would be, or my top will be row -1 column, my right will be row column +1, my left will be row column -1, and my bottom will be row +1 column, right? And I think one more case I should not forget, which is the second case I took. So if my start color equal to new color, I will simply return the image, input image, right? If that is not the case, I will walk through my field color, which is one column, let's hand this. So it worked. I just check for one more example. So in this case, my start and end color are equal, so it will simply return the image. Let's submit this. Got accepted. Oh, 99.62%. That's pretty great. Okay. So the time complexity of this solution would be, so though it look like it will be exponential, because we are having multiple recursive calls inside one recursive function, but if you look at it more like deeply, you got to know that each of the cell will be visited just once because of this condition. So we are just going to call this recursively when my current pixel is equal to starting pixel. So in that case, if that is marked as the new color, then it will not be traversed again, right? Because its color will get changed. So in that case, the actual time complexity will be rows into column, like number of rows into number of column, n into m you can say, and the space complexity will be constant. So yeah, I think it's pretty great and neat solution. So we'll stay tuned in. We'll see you tomorrow for the next video.